How you doing, Twitch chat? How we doing today? My name is James Spencer. Welcome to Howdy Partner. Today, I'm joined by my good friend and colleague, Olabanji. Olabanji, how are you doing today?
Good. How's everyone doing? My name is Olabanji, and good to have you guys on the show.
Yeah, good. It's good to have you. Today we have, well, first of all, Howdy Partner. For those people first joining us, Howdy Partner is our weekly Twitch show we have on the AWS Twitch channel, where we bring our partners, part of the APN, the AWS Partner Network, on to show us what they've built using AWS services, how they can help make your life easier, make it better, optimize your workloads, anything like that. All sorts of cool, interesting stuff. So today we have HPE Aruba, and they're going to show us some networking. Olabanji, you're the networking guru. Uh, Tell us a little bit. I don't know. Maybe you can speak to a tiny bit before we actually bring them all on.
Aruba is going to be demonstrating their new technology, SD-WAN, and how it can operate uh, in different edge locations around the globe. I'm excited to see what they have going on and how this technology works. So I'm looking forward to what they're about to show. Case.
Awesome. Yeah, without further ado, well, first let me point out we do have a message pinned in the top of the chat. If you want to connect with Aruba, it's going to be there the whole time. I'm going to mention it a bunch of times. Go to that form and fill it out, and they will connect with you and get you hooked up. All right, without further ado, let's go ahead and bring on Adam, Fraser, and Dinesh. Fraser, Dinesh. Surprise. Hey guys,
Yeah,
how you doing today?
pretty good.
Great.
How are you guys
Good,
doing?
Really good.
good,
Howdy.
good.
Howdy.
Yeah.
Howdy.
Howdy.
So I guess let's go through some quick intros. Oh, Adam, you
Yeah,
want to go
there's
first?
yeah,
It's
yeah. So
okay.
this is gonna be a problem. We're gonna have to guys gonna have to go in
It's
the
okay.
backyard.
He's just
Yeah,
trying
Got
to
mine's
be
a
on the
little different.
show.
I got mine right here.
Yeah.
Mine has to. It's the worst possible time is always when they decide to show up. So my name is Adam Powers. I am a product manager with the Aruba SD-WAN product line. I was been working on SD-WAN products for SD-WAN technology since it began 10 plus years. Was originally part of Silver Peak. Silver Peak got acquired by Aruba, and now we are a part of the Aruba ecosystem. Have been deploying and managing production SD-WAN networks for a very long time. I am a product manager, but I also have a lot of operational sort of production experience and knowledge, and can talk about a variety of different aspects of SD-WAN. If you guys have questions or want to get down into the nitty gritty of what SD-WANs do and how they work, more importantly, how we can use SD-WANs in combination with AWS infrastructure to make your network better. I'm the person for that.
Awesome. Yeah, I know what a WAN is, wide area network, but I'm not familiar with the SD part of it necessarily, so I'm interested in this. Dinesh, how are you
Yep,
doing?
thanks. Great. Great to be here. My name is Dinesh Fernando. I'm also a product manager. Um, been focusing mainly on public cloud infrastructure, uh, SD-WAN deployments, and mainly AWS, Azure, and GCP. Similar to Adam, I've joined the Aruba enterprise as part of the Silver Peak acquisition, and also I've been working uh, in the Silver Peak plus Aruba team for 10 plus years now.
Wow. That's a good tenure. I'm impressed. Lastly, Fraser, how are
Hey,
you doing?
good. Hanging in. And you?
Good. Good.
All right. Similar story for me. I'm coming in from the Aruba, into Aruba through the Silver Peak acquisition. So I've been working with Adam and Dinesh since day one, which was 7 years ago for me at Silver Peak. My responsibility has been really managing all of our technology alliances. And so from the get-go, that's been AWS, along with a lot of folks in the security space. The other major area, cloud security are the two big domains where we've done a lot of alliance work. So AWS has been, kind of my primary partner for years now, and it's great to see this solution and how it's developed from the first use cases of getting our product into the marketplace up through really advanced integrations that we'll show you guys today, and all kinds of ways that we can make basically any enterprise who is looking to interwork their wide area network, their business network with AWS, we can make that work a lot better with the solutions that we support. So super excited to take everybody through that today.
Awesome. Before we dive into that, I heard you mention marketplace. Can I dig up an AWS marketplace listing for everybody? Is that
That's for sure. You go in there. Actually, today you still might want to type Silver Peak into the AWS marketplace, although you can find other Aruba solutions. And we're just now in the process of getting. It's actually a non-trivial to migrate listings in the marketplace, which is completely reasonable. But there's a lot that goes into it, and so we're just migrating our listings from Silver Peak over to an Aruba kind of presentation, and that's happening. Dinesh is leading that work right now, but if you type silver space peak into marketplace, you should get some hits, including the relevant ones for this solution, EdgeConnect and Orchestrator.
Yeah, I think I found it. Silver Peak Unity EdgeConnect.
That's it.
That's right.
There we go.
EdgeConnect is the main. That's right.
That is exactly it. That's the EdgeConnect brand is what we use for this solution.
Awesome. Okay.
So that's what we're talking about
so
right there.
I'll make sure to keep pumping those links out for you guys. I guess let's kick it over to you. What do you got for us? Who's leading off here? Who's on first?
I think I was going to go first with just a few slides to orient everybody to Aruba and HPE. So less than 5 minutes, I hope, and I also remind folks that there is a link that's gone into the chat for a form that anyone who's watching this, I guess now or later, really will leave the link up there we'll leave the form up for a while, can fill out a trivial little form to put name and address, name, phone number, email address, and we can get back to you if you want any kind of contact from us, from the Aruba folks. So please fill that out if you'd like to hear from us in any regard. So I guess Dinesh, do you want to share the slides, and I'll blaze through those and turn it over to you guys?
Yeah,
right.
I'm sharing my screen. Yep.
There we go.
Good deal. Yeah. So look, that's the title of today's session: simplifying connectivity. So simplifying, making things more efficient and higher performance. So here we go. Page down again, really quickly. So we come from the HPE Aruba, the Aruba business unit within Hewlett Packard Enterprise. I'll show you a slide later on about the overall kind of architecture of HPE. But if you think way back, remember everyone that Hewlett Packard and Hewlett Packard Enterprise separated back in around 2015. So we are the kind of server storage, networking, and enterprise business part of what you used to think of as HP, and the printers and laptops and other consumer devices are all in the HP business, which are entirely separate from HPE. So you're talking HPE, and within HPE, we are the Aruba BU. We do about, now that 3 billion a year is really about 4. We're doing just over $1 billion a quarter in this business, thousands of employees out of about 60,000 total. And Aruba, for folks that are familiar with that brand and that name, dates back to the around 2003, I think, give or take, and is really a leader in enterprise Wi-Fi. So next slide, we can talk about kind of that progression from 2002. Aruba as a startup that was acquired by HPE was really drove the market, the development of Wi-Fi, along with a couple of other startups. They were in a controllerless kind of architecture, a whole ton of innovations that they've pushed out over the last 20 years around Wi-Fi technology. And the piece of this today, if you look forward over to the right, that we're going to be focused on is the acquisition of Silver Peak and SD-WAN, which you see is the second to the rightmost of the segments around the time of COVID. We got brought into HPE. It was a super $925 million, so a pretty significant acquisition for HPE of Silver Peak, and brought in a Gartner Magic Quadrant leader in SD-WAN into the portfolio. And just this year, we've also added on to that a really important component with the acquisition of Axis, AXIS. cloud security solutions. So we'll probably get to pieces of what Access brings into the portfolio today, but they really complement our offering. And so now we've got a awesome market-leading software-defined WAN solution that integrates in all kinds of amazing ways with AWS, and it's also now attached to this cloud security component, which Access brought to us, and that altogether is a solution that folks also refer to as SASE, Secure Access Service Edge, which may be a acronym that's familiar to people. So that's kind of the domain that we're in today. Page down. Here's a quick look at HPE overall, and actually the formatting here looks it's not perfect, Dinesh, but it's okay. So this is you see us as the networking box within this bigger technology conglomerate that is HPE. So server, storage, networking, a lot of cloud management software, other security software, analytics, Hadoop, all manner of different kinds of enterprise IT technologies that are part of HPE. HPE is 60,000 employees, and I think about $28 billion a year in revenue. So with our last quarter, the Aruba part that we're from, the Aruba business, the networking business, is about, I think, 15% or so of HPE's overall revenues. So it's dominated by compute and storage. Next slide, please. So this is the architecture that we use in our business. So real quickly to sort of, again, orient you to how we think about networking in general. So Aruba, in terms of our portfolio, office solutions you see across the top that span from remote single employee offices, home offices, branches, clouds, campus network, and data center. So wireless, whether that's Wi-Fi technology, the SD-WAN solutions, data center switching, we have all of it. The way that we think about that in terms of the overall portfolio is centralized management technology. We'll be talking about the centralized management part of the SD-WAN solution called Unity Orchestrator, EdgeConnect Orchestrator. Aruba Orchestrator today. There's also another management product called Aruba Central that is integrated with our Orchestrator to provide a single pane of glass experience for users. And then sort of these layers of the cake from the lower layer where we talk about all of the things that connect users and applications to the network. The piece that we're targeting today, again, is the SD-WAN piece. And then the protect layer where we offer on the right hand side, you see that SASE acronym again. So cloud security and the integration of security into SD-WAN. The dynamic segmentation piece right in the middle of that layer is super important. And when we talk about AWS Cloud WAN, you'll see the segmentation piece that AWS delivers unified with the segmentation that we do in our SD-WAN and in our deeper into the network, which is really cool. That end-to-end kind of segmentation, traffic visibility, and monitoring are all integral parts of it.
Oh no.
Uh-oh.
Fraser, come back to us.
We need to get Fraser some SD-WAN.
Yeah,
Yes.
right, I guess. Okay, well, let's bring Olabanji back.
What,
there.
am I back?
Hey, you're
Hey,
back.
there he is. Okay.
Good. Oh,
You're back.
hey,
You're
my
back.
screen went black and I was like, what's going on? But everything looks fine here. Apologies. Yeah. All right. Well, hey, Dinesh, page down. So I was taking you guys through kind of the elements of this architecture. So again, today, from a Connect perspective, it's SD-WAN that we're focused on. Hit page down again and go through to the next slide. So the EdgeConnect fabric and the elements of that are the focus. Hit page down here. On the security side, SASE, the dynamic segmentation thing I was talking about, and visibility are all pieces of the solution. And last but not least, the automate piece. So you'll see Dinesh and Adam are going to take us through a bunch of automation that we do for instantiating our solution into AWS through kind of a one-click experience in our orchestrator, and then automation that we do for interworking the SD-WAN with other AWS services. So that's really central to everything we do. And at kind of the scale you deploy these networks, if you're not automating it, you're really not going to have a great user experience. So those are the sort of technology elements. I think the last slide here is kind of the breadth of our solution. So if you have any questions about how Aruba and AWS work together. We have landing pages on our site that talk about all the different ways we touch AWS Outposts, the network integrations, ClearPass, a whole bunch of the NAC solution runs in AWS, so a whole bunch of different ways that we interwork with AWS today and collaborate with them in our alliance. So that's basically it, I think.
Nice.
Hopefully most of that came through. I don't know what the glitch was there. Apologies.
No, yeah, I didn't think we missed anything really. My two favorite things from that was the zero trust part of it, and the automation part of it. Those are, I've noticed recently. I don't know about anyone else, but zero trust has been kind of like a thing I've been hearing it coming up a lot lately. And totally, if you can't automate stuff, then it's kind of like automation is the key to part of this key to the consistency and optimization.
Scaling the stuff out, right?
Yeah.
Requires that.
Yeah.
Yep. And you'll see that last thing I'll say is you'll see as the demonstrations go on here about how the SD-WAN functions, real uniformity between how the SD-WAN is operating in AWS and how it would operate down in your physical branch. Because at the end of the day, kind of the core of our business is enabling brick and mortar enterprises who have distributed, offices, right? Those offices to connect in to the data center locations and into AWS, where most of the data center activity is sort of moving. And so the way the SD-WAN works when it's a physical appliance in your wiring closet, and the way it works when it's a virtual appliance on an EC2 instance in your VPC, it's uniform, it's presented to you in a uniform way, and that's one of the things that makes this really easy for customers to get their minds around and admins to get their minds around when they come to operating the network. So
cool. Yeah. Awesome. So with that, Adam, all right, I guess, did you have something to show us, or?
Yeah, so we got like a bunch of ways we can go here. Dinesh,
Yep.
you have a slide that talks through a couple different,
Yep.
you have a couple use cases. I think
Yeah.
we were like,
let
well,
me-
which one of these? The question is, first of all, that what is SD-WAN, and how does it intersect with AWS cloud-based infrastructure? There are a variety of different use cases we can talk through. Let's see which one we've got here. Yeah, let's start here. So we've got a couple different things we want to mention or kind of go through. The first one is called ruggedized first mile. This is a pretty novel approach to providing ultra robust connectivity for branch offices that just absolutely cannot get disconnected from the internet. So I am a World of Warcraft player. We do rated battlegrounds, RBGs. There's 10 players on each side, and if you disconnect in the middle of a rated battleground, it is bad. People do not like it. I play a DK. I am typically the target caller, and I spin the flag. And if I go away for a couple minutes while I'm reconnecting, they will cap, and I will be a very unpopular person on that particular team. We play at the 2200 range. So if one player goes away, that team is probably going to lose. What the ruggedized first mile does, and this feature is literally born out of me getting disconnected from. I've literally was like, how can I not ever get disconnected? So the way it works is SD-WANs, you give them multiple internet connections, as many as you can afford. If you're a large enterprise, you're historically purchasing MPLS connections, dedicated point-to-point links, $1,000+ a month. So you're accustomed to paying top dollar for connectivity at branch locations. What the SD-WAN product says is you can keep those expensive MPLS, point-to-point, Metro E connectivity technologies if you want, but the better approach is to bring in multiple traditional consumer-grade internet connections. For instance, here at my house in Atlanta, Georgia, believe it or not, I have Comcast at 300 meg. I have AT&T optical internet, realistically about 700 megabits per second. I have a Starlink residential antenna on top of my house, and also have a T-Mobile 5G home edition device. So I have four what we call underlays, or four different high-speed internet connections. Any four of the which would provide decent connectivity. Maybe not the T-Mobile one. Any four of those links would connect me to a World of Warcraft rated battleground and do a pretty decent job. So what the SD-WAN does is it takes all four of those connections and it bonds them together into a single tunnel called an overlay tunnel or a bonded tunnel. And you connect that tunnel to an AWS EdgeConnect. So you have an EdgeConnect at your house. Well, in my case, at my house. If you're an enterprise, you have an EdgeConnect at your branch location. And that EdgeConnect across all four of your internet providers, or maybe you only have two, however many you have, it connects to an EdgeConnect running in AWS. And then at that EdgeConnect in AWS, you assign an elastic IP into which your traffic will be natted. So the idea is, I'm in Atlanta, Georgia. I want to connect to, BattleNet. I want to connect to, or League of Legends is another one. Never want to get disconnected from a League of Legends match. So World of Warcraft, League of Legends, you route that traffic across the bonded tunnel to AWS, and then you break the traffic out locally, route the traffic out locally into the internet from that AWS IP address. Now, the reason why this is so effective is if any of the connections, if any of the individual internet connections drop, or if packets are lost over any of those individual internet connections, the other connections are already there, ready to go, supporting the traffic. So what the EdgeConnect does is it takes, so I have four internet connections, it rates them. It looks at latency, loss, MOS, jitter, and some metrics related to how healthy those connections are. It puts the World of Warcraft traffic on the primary link, and it effectively copies the traffic onto the second best link. So it is constantly sending my traffic two different ways to AWS. Once the traffic gets to AWS, it recombines, it takes one unique copy of the traffic and sends it out across the elastic IP onto the game servers or onto the voice servers. Again, this, I'm kind of being silly with regard to, you're not going to be playing games from your enterprise branch office, at least not during the daytime, but it works. This technique of sort of protecting or ruggedizing the connection, the first mile from the branch onto the internet backbone, provides this hitless mechanism. So you can pull out an internet connection, you could drop a packet and no one notices. It's utterly and completely transparent to the to the flow, to the actual application. So
I have a quick question, Adam,
yeah,
concerning that. That's a very interesting topic you mentioned. So, on the back end at AWS, does the speed or the quality of lines matter?
yeah. Well, so once the traffic, the general idea, philosophy is that if you can get the packets to the AWS backbone, what we call the middle mile, if you can get the traffic to AWS, the chance of AWS having a connectivity problem to Blizzard or to Zoom or to Teams or anything else for that matter is very low. The problems you experience with regard to the internet or internet connectivity are almost always in the first mile. So the problems are, if you can get the packets, you can escort those packets across the first mile, get them into the highly available high-speed internet backbone, then it's just a short hop, couple of milliseconds or whatever, from the AWS Elastic IP point to the application that you're wanting to interact with. So there is the only downside to this is that if you think about a traditional internet connection, your packets leave your house and they go directly to the game server, or they go directly to zoom.com or whatever. We call that local breakout. That's where you're not backhauling your traffic across a bonded, protected tunnel into AWS and then to the end destination. You're routing your traffic directly from the branch location straight to the into the endpoint. The only challenge with this ruggedized first mile thing is that you do take a backhaul tax. So there is a certain number of milliseconds you're sort of going out of your way. Instead of going directly to the application, you're going to AWS first and then to the application. So for me here in Atlanta, Georgia, the latency over AT&T is 18 milliseconds to North Virginia. So from Atlanta, Georgia to Virginia, it's about 18 to 22 milliseconds. So I'm accumulating about 20 milliseconds worth of latency on the front end. And then from AWS to wherever else I'm going is the additional, the remainder of the latency. So the idea is you trade in this backhaul tax, you trade in this 10, 15, 20 milliseconds worth of backhaul latency for the ruggedized, hitless, sort of unbeatable internet connectivity. The key though is having more than one internet connection. So that is the main thing.
And that latency, that latency you're measuring to AWS, Adam, to be fair, there's going to be a latency contribution from the analogous portion of the internet service as well. So it's not as if it's 15 or 20 milliseconds against 0 when you're doing local breakout. There's something that is, there's a comparable latency, right? If I'm understanding, you
The
always
general
use
idea is
numbers
that
in an additive way.
AWS has really good peering with anywhere you want to go. So once you get your packets to the AWS,
You're next door in Ashburn, Virginia, to all
that's
these
right.
business services are all there.
Absolutely. Once you get to Reston or Ashburn or wherever the AWS infrastructure is, you're in the mix. You're in the backbone at that point, and it's going to be a pretty short hop to most applications that you'd want to interact with.
Again, just to add to that, if you take a look at the global footprint, you'd see that outside of just traffic moving from one point to another, there are regional edge caches. There are, this content delivery network that makes your whatever traffic you're sending to go at a much faster rate using the AWS's backbone network.
Yeah, that's right. In fact, I'll mention it. Speedtest.globalaccelerator.aws. Really good demo. You guys can you can plug it in your browser now and hit go, hit start. That illustrates. It really illustrates what I'm talking about. It's in that case, it'll show you a page that will compare if you went directly from your browser to the thing versus directly from your browser across these accelerated network edge components, and what the difference is between direct internet connection versus globally accelerated internet connectivity. And in most cases, you'll see that the globally accelerated latencies are lower. The performance is better.
Yeah. So with that being said, Adam, do you want to show like how easy it is to deploy an EdgeConnect instance from our orchestrator into AWS?
Yeah, that's right. So there's the EdgeConnect. One of the problems we ran into, I know that I ran into early on. We first started doing this kind of stuff. We started telling people, look, if you put an EdgeConnect, if you put an SD-WAN router in a cloud environment in AWS, you'll get all these benefits. You now have a cloud router. You can do hub and spoke deployments. You can on ramp your traffic through that. The challenge with it is configuring and deploying it. So setting up an EdgeConnect by hand, deploying the AMI, mapping the VNICs to IP addresses and MAC addresses and stuff is kind of it's a hassle. It is not an enjoyable experience. So what we did was we automated that. We made it very easy to deploy and configure an EdgeConnect in AWS without having to mess with all the little artifacts and bits and pieces. So let's see. I think we can just demo this, kind of show it live. Dinesh, I have okay, so you have screenshots of it. We could probably just let it run. We'll just start one up and let it cook and kind of show this in action. I think showing the SD-WAN environment would probably be a pretty useful way of going about it. I can actually present this if you want.
Yeah.
And this is the use case to start with if you're looking to get, if you have an EdgeConnect SD-WAN and you want to experiment with these deployments in AWS, this is the easy way to start. A lot of the other use cases we have will build on this sort of ruggedized first mile, and this automation of the EdgeConnect being spun up in the VPC is kind of the foundation for all of it.
Yeah, so hopefully I'm sharing the right thing. You guys see a Aruba orchestrator here?
Yeah, Adam, you want me to pull yours up?
Not quite yet. We're seeing the slide.
Right. Yeah, switch to me here for a second.
Yeah,
let's take a.
And just real quick, what was that link you said? Was it speed test dot?
That's right. speedtest.globalaccelerator.aws.
Yeah. Okay. I'm gonna check that
This
out.
is
Yeah.
it's a pretty showy thing that
I think
AWS has done here. It's
that's an
pretty,
unfair comparison because you're using the global accelerator to transport your traffic.
yeah, but you can. So I don't have a demo prepped for this, but you can use a globally accelerated IP address to terminate the tunnels from an EdgeConnect branch location. We don't typically do that. It's a little overpowered / expensive for, I don't know, expensive is the right term. It's just more than what a lot of customers need, but you actually can use the global accelerator to terminate tunnels and proxy tunnels from one point to another if you choose to. But I guess my main point with the global accelerator speed test demo is it kind of illustrates once you get packets to the AWS backbone, they're going to perform better for the rest of the trip. So the packets make their way across the stable sort of ruggedized environment that AWS provides for its own backbone services, and it's just a better experience for most people. So let's do this real quick. So this is an SD-WAN fabric. Is the way we refer to this. This is called the Aruba Orchestrator. This deployment here is used by a lot of the SEs and the sales folks and engineers within the Aruba team. And we have all these blue dots are individual edge connects that are deployed all over the country. So we're all over the globe for that matter, across Europe, into Asia. We're going to focus mostly on North America. Notice in the left side over here. Now, I know this is an AWS thing, so you're going to see some other brands in the hub list over here on the left side, but that's okay. It's mostly orange. So this, if you can see, I might need to zoom
Could
in
you
just a
zoom
little
in
bit.
just a little,
Yeah, it's pretty.
if possible?
Do it.
Hey, there we go.
Let's
Thanks.
get the right there, then we can see a bit better. So what I have selected here is the hub group. These are the these are the hubs that provide connectivity between all of the branches in each one of the locations. So you have a variety of different SD-WAN topologies that you can deploy. A topology would be like, if I've got branch offices, how am I going to interconnect them? Do I want to do a hub and spoke? Do I want to do a mesh topology? Do we want to do regional hub and spoke, regional mesh? You've got a bunch of different options that we can get into and talk about. This topology this is showing a regional hub and spoke. That means that for the for each region, like on the West Coast, on the East Coast here, we've got all of our edge connects. These blue dots are individual branch locations all up and down the East Coast. All of these devices connect to these three hubs on the East Coast. We've got an AWS hub, an Equinix hub, and a Megaport hub. Ignore these two. The AWS one is the one that matters in this case. The AWS hub in this case is the primary. You can set these up to be active backup. You can set it up in a variety of different ways. In the East Coast region here, within this SD-WAN fabric, this East 2 guy is the primary. So now let's say that we want to, I don't know, Dinesh, how should we do it? Let's spin up a new region. So let's go to configuration. And let's say that we've got folks in South America that we've got offices we want to stand up in South America. We do currently, I think that I might already have a Sao Paulo device. Yes, let's do another one. So we're gonna set up a new EdgeConnect hub in South America, and we want to deploy and have a device available in the South American region. We just go to configuration, and we can use this deploy cloud hub in AWS option. So we click this guy and go to new deployment. We give it a name. Let's call it Southam 2. We're gonna pick the account. So if you're an Aruba EdgeConnect customer, you need to work with your IT guys. They will give you an API key that has permissions to configure and deploy. We're running Terraform in the back end. It's interacting with AWS to create all the artifacts, the VPC, the virtual NICs, elastic IPs, security groups. All of that stuff is orchestrated and configured for you. So I'm going to pick that account that I've already configured the credentials for. We're going to pick what region we want. So the region here is driven by whichever account we select. Let's find Let's do South America. Let's give it a. We need to find a IP range that is not in use. Hold on just a second. Let's go find this one. We'll go to configuration, routes. So this is how I do IPAM: is go to the route table and find a network that is not already listed in the route table. You should not do it that way. This is only, it's because this is a quasi production network, and we don't care too much about in a real network, in a real enterprise environment, you'd have a pretty well managed list of IP ranges. But I'm just going to randomly pick 192.168.27.0/24, and
So
if I
do as I do, not as, or do as I say, not as I
yeah
do, kind of thing.
yeah the problem with doing it this way is that, like, I'm looking for an IP range to use for the VPC, right? And I want to make sure that this IP range is not already in use within my fabric. And the way I'm doing that is by looking at the current active fabric routing table. Well, what if there's a branch that's just offline right now that has 192.168.27.0/24, and it's going to come back on later tonight, and now we're going to have overlapping IPs, the same subnet at two different branches. That's going to be a bad thing. Again, for regular enterprises, they will have a spreadsheet or some IPAM software or some other mechanism for assigning and allocating IP ranges. That's not how this network is run. Unfortunately, it's the Wild West, and you just take whatever IP is available currently. So I can tell that this one is not taken, because notice that it is not. There are no routes being returned from any hubs that have the subnet range, which is good. So now let's pop back over here and let's use 192.168.27.0/24, and then we'll tell it we want to use Adam's key. Now, one of the things that SD-WANs do is this thing called WAN optimization, or we call it Boost. WAN optimization is a technology that at this point is probably 15, 18 years old. It is a compression, deduplication, and optimization technology for network traffic. So Silver Peak, the company that Dinesh and I originally worked for before we were acquired by Aruba, Silver Peak started out as a WAN optimization technology. We would compete with companies like Riverbed, who I believe is now all but dead, unfortunately for them. We kind of transcended, we moved on. We said, you know what, WAN optimization is cool and all, but it's better when it's coupled with a more broad router technology, which is referred to as SD-WAN. Just a real quick note on that one also, SD-WANs replace traditional routers. So if you're like me and you started many years ago noodling around with Cisco routers, iOS, you're working on your CCIE, you're doing CLI stuff, you're learning about just good old-fashioned hardcore Cisco routers, what you would do is deploy an ISR at a branch location, at all of your branch locations. And if you wanted to manage that ISR, that Cisco edge router, you would SSH or Telnet back in the day into the device and use the CLI to configure it and do all your work. That went on for like 20 years. Like, in fact, a lot of people still manage their router infrastructure that way by hand through the CLI. SD-WANs do not work that way. In the SD-WAN world, almost everything is done via automation, is done via web UIs like you see here, where it's kind of point and click your way through to success. You still need to understand networking principles. You still need to understand how networks work. But all of the heavy lifting and repetitive work associated with configuring things goes away. It's replaced. It's fully done by automation. This is another good example. We used to manually deploy EdgeConnect SD-WAN routers in AWS by hand via an AMI. Now I can use this web-based UI to point and click my way to having an EdgeConnect router deployed in this case, the South American region in Sao Paulo. Get back to my original point. WAN optimization is part of one of the features that's provided by the EdgeConnect SD-WAN solution. What it does is it primarily dedupes and compresses traffic. So as long as the traffic is not encrypted, of course, if something is encrypted, you cannot compress it because there's simply not possible. if it's like CIFS traffic, or if it's HTTP, or anything that is not either already encrypted or already compressed, the EdgeConnect will do that for you. It's like, imagine you're going to like zip a file. Imagine you zipped every byte that you send out of your branch location to the internet. Every single thing that you send from the branch out to the internet gets zipped and sent on its way. That's what the WAN optimization mechanism is doing. It also optimizes TCP, so it changes and modifies the way TCP operates. It modifies the way congestion avoidance works. It changes, sort of optimizes TCP behaviors such that when you have high latency, maybe 100, 150, 200 milliseconds or more, the WAN optimization mechanism will boost the traffic and cause you to get higher throughput, to get better performance. So WAN optimization is a mechanism for optimizing the WAN side of your router at your branch locations. In our world, we just basically say optimize or not. So I'm going to hit boost, which means I'm going to use WAN optimization. You tell it how much traffic you want to boost up to. Let's tell it we want a device that can do up to 200 megabits per second. We then specify our availability zone. I'm going to put it in, let's do East 1A. I'm going to give it an appliance tag here, which do A powers, so that when the device is deployed and all the artifacts are provisioned, people will know that they came from me, from A powers. Another thing that we do, so our DevOps people don't get upset, is we do an owner equals A powers in the AWS tag section, like that. It's very important. Now that tag will be associated with all the artifacts that are created by the automation process. Again, so that if people want to go and say, "Hey, Adam, how much are you spending on backhauling World of Warcraft traffic through AWS?" they can simply reference the owner equals A powers and get an accumulated cost for all the artifacts that I've created through this automation. Okay, so now all that's done, all I have to do is review and deploy. And what I do, I forgot the instance type. Yeah, that's right.
Instance type.
Just to say, all in for like a real enterprise deployment. If you're not pumping like tons of video through this, or got some kind of extreme workload, for normal enterprise use cases, a few $100s a month,
Yeah.
all in for the EC2 instance plus some egress bandwidth. That's a kind of order of magnitude of money you're talking about for running one of these instances in a real production environment.
Yeah.
Right.
Plus, to add to what Adam mentioned, now when he selected the WAN bandwidth and when he selected boost, like based on the WAN bandwidth, we show the recommended instant type under the instant type drop-down menu. So if he selected, like, let's say 1 gigabits per second and he wants boost, then the recommended instant type changes automatically, like based on the requirements.
Goes all the way up to a C4 8X extra large, right? Gets much bigger. The boost mechanism, if you turn on boost, it's compressing, it's deduplicating the traffic, it's proxying TCP. You need much more compute, you need a much more powerful instance to do heavy boosting. If you choose not to use the WAN optimization mechanism, you can get away with a smaller instance size. So let's not do a 1 gig device here, because that would make me unpopular with our DevOps guys. All right, let's pick just the smallest one we can get away with, which is C4 2 extra large. Now we're all set. So we picked a couple things where we want to do it, what region we want to go with, our site or subnet range, the size of the instance. Now all we have to do is hit review and deploy, and then just hit the deploy button.
Yeah.
And
one more thing while it's deploying, if a user needs more than one EdgeConnect instance, it's just a one click to create more than one on that previous page.
That's right. I forgot to show that.
No
Yeah, you can
problem.
have it spin up 2 or 3 at a time if you want, like a primary and a backup, or 2 primaries. I just selected one in this case. You can see there are a couple others here where there's more than one instance that's already been provisioned.
Yeah.
Little birdie was mentioning in my ear, talking about the software, the SD part of it, versus traditional type of routing. So basically this is managing everything through this orchestrator versus kind of doing it in the CLI, just box by box and such. This is kind of just the central thing. You don't have to do it like
The
we keep saying
controller.
automation and manually and stuff
In general,
like that.
you don't ever go into the CLI or manage our boxes individually by
Yeah.
device to device. You're always in this orchestration system.
Yeah, that's true. But having said that, guys, there are a lot of people in a lot of situations in which you still need access to a CLI. These devices, these SD-WAN routers, do still have a traditional CLI. In fact, if you want to get to the CLI, you just click this little guy and then just go CLI session. And so
Okay.
this is just going to drop me into the CLI in this device that's in Mumbai. At least I assume it will. I don't know what.
Yeah, but that's super
Only when you want to
handy.
demo something does it not work, right? That seems to be the case.
Yeah.
But it's just one click. There are a couple of reasons why you still end up hitting the CLI. It usually has to do with when I want to run a PCAP. If I'm really wanting to get quick access and figure out what's going on the wire, running a TCP dump or a PCAP, even running a ping from the local appliance is a good way to go. I don't know what's happened to my CLI session. Anyway, there is still a CLI. It's available. It's just you just don't need it, right? And I think there are some people early on in the SD-WAN days, we would hire folks from Cisco, and the first thing they want to do is figure out everything about the CLI. They want to learn all the commands and how to set up an EdgeConnect using the CLI, and they just waste a lot of time doing that because I'd be like, yo, you're never going to use that. Like you do not, as an SE or as a technical, as an installer of an SD-WAN system, you do not really need to know much about the command line interface. You need to spend your time thinking about networking, like not what are the semantics of the way the commands are configured in this or that product. Think logically about topologies and routing domains and filtering and how you're going to connect stuff. So you spend more time thinking about how you really internetwork things as opposed to what are the semantics for this particular type of CLI on this particular type of router or platform. So there's nothing. It's like people say, "Oh, well, real men use CLIs," like or real women, men, whatever. That's silly. Like those people are just wasting their time doing that stuff. If you can get a web UI to do everything for you, and you don't have to use a CLI, you should take that. You should take the opportunity. And so it's very rare that we need to resort to using the CLI for the EdgeConnect SD-WAN product.
And the theme of the product is that you're trying to configure these things in a uniform way, even recognizing that there may be differences site to site in terms of what WAN interfaces you have or connectivities available. You still are trying to push down a uniform business policy. And so that requires the orchestrator to synthesize all that stuff and figure out how do I push that to these devices in a way that they're all going to behave in a way that's going to give me the business result uniformly across the network.
That's right. So those are called snowflakes. So snowflakes are the enemy of availability and configuration conformity. You do not want to be making individual configurations that are specific to one appliance if you can help it. We're going to minimize the number of branch or location specific configuration elements everywhere possible. So we use things called templates, we use orchestration, and we use business intent overlays to provide sort of you'll see in a minute. We're gonna once this device is it might take a few minutes. We need to talk about something else while it's kind of it's running here. But once this is done, we'll add this EdgeConnect from this AWS based EdgeConnect into our SD-WAN fabric, and you'll see that we're going to apply some stuff, but we don't really have to do a whole lot of specific configurations to that appliance. Problem with snowflakes is you forget about them. Like if you have specific things you've done in specific places, you go on vacation or you leave, somebody comes in behind you and they have to go and discover those snowflakes. They have to figure out and relearn all of these novel, clever tricks that you did at some branch location to get it to work correctly. It was clever at the time, but it won't be in the long run when somebody else has to come behind you and work out what you were thinking or doing. So we try to do everything through templates, through automation, and through sort of standardized best practices and uniform configurations.
Cool. Hey, Adam, just real quick while we're waiting for that deploy. Welcome to Howdy Partner, everybody. If you're just tuning in, we are with our partners from HPE Aruba. I'm joined by my colleague Olabanji, and from HPE Aruba, we have Adam, Fraser, and Dinesh. they're showing us the SD-WAN EdgeConnect fabric, and just showing how, I mean, how everything is working. And right now we're deploying, what exactly are we deploying again? I'm sorry, Adam.
No, we're spinning up a virtual SD-WAN router in
Yeah.
Sao Paulo
Yeah.
currently. So we're adding a hub. So imagine we're going to open new branch offices in South America. We want those branch offices to be able to communicate to each other. We also want them to be able to talk back to the mothership in North America or in Europe. This is going to provide sort of an anchor point or a routing presence in Sao Paulo that we can use to um, connect branches within South America.
So all
So
those,
behind the curtain, actually what's happening is that the orchestrator is taking all the information that Adam provided, such as the VPC CIDR block and the instant type that the AWS network needs to bring up. And the orchestrator is basically creating a brand new VPC. It's creating 3 subnets inside it because the EdgeConnect, the virtual machine, has 3 interfaces. So it's creating 3 subnets. At the same time, it's creating the security groups and the security rules inside each of the security groups. It's assigning the public IP addresses on the internet-facing interface on the virtual machine, and also enabling IP forwarding. So it's doing quite a bit of things at the moment. And once everything is done, the virtual machine appears on the orchestrator. And Adam will show that to you in a minute or two. Um, and from that point onwards, it's like any other EdgeConnect virtual machine that you deployed in your EdgeConnect SD-WAN fabric. It just looks like another branch office to in this SD-WAN fabric.
Fail. It's a fail on this one. I suspect. So a quick pro tip. I was afraid of this, Dinesh. I didn't check before we started. By default, a VPC can have five elastic IPs. I do not think that Sao
A
Paulo is
region, a region.
per region. I don't think the Sao Paulo is increased. I meant to
Okay.
check before we started, and I did not. So
Yeah,
you might have
but
to check for me because I do want to. I want to get this going. We'll move on, but I
yeah.
want to show this provisioning and bringing a device in through this automation. All you have to do to fix that is I think you just open a support ticket with AWS and ask them to increase the per region VPC elastic IP limit. I doubt we
the
did that for
quota.
Sao Paulo.
Yeah.
The quota.
Yeah, the
In
service
fact,
limit.
we can quickly show the error message. Just takes a few seconds if you click on that incomplete button there.
Yeah.
All those
And
battlegrounds players in Sao Paulo, Adam, like they're all doomed.
That's right. That's God, what is the name of the realm that they all play on one? They all play on one realm. Like here's
On the same server.
yeah. It's called I'll remember here in a minute.
I was a mage and I was terrible. People asked me never to PvP, so
Yeah, I'm my kids carry me. I have 2 boys. They both play at very high level, so they just carry me around. Dinesh, looks like something has changed since I last tried this, and my
um,
Vignesh changed. He did some work recently on privileges related to API keys, and
I see.
this is
Yeah.
probably that. I should have done one of these before this thing started. So bad on me. But so there's really two things you have to be careful with when you're doing automation like this. One, you got to have the right permissions, and 2, got to make sure the quotas are set properly. So there's one of 2 things this issue could have been: either not enough elastic IPs in that region, they're all used up, quotas met, or what you see here, which is you are not authorized to perform this operation. So that's sad. That's very sad.
and this deployment, I think you mentioned it. It's kind of behind the scenes. It's using Terraform or
Yes, that's right. So Terraform is installed in our orchestrator.
got it.
So basically,
Okay.
it is invoking all the Terraform commands, and Terraform is sitting in between AWS and the orchestrator, and it's creating the VPCs and the other relevant resources for the virtual machine to be up and running.
Cool.
Yeah, that's right. So let's salvage this a little bit. Let's take one of these ones that are already deployed, and if we click the deployment info, you can kind of see all of this stuff here is what the automation carved out for you. So it carves out a management interface, and it gives a elastic IP to the management interface. It's purely for management and connecting to the orchestrator, and it gives a WAN side interface. So there'll be a WAN side IP and a LAN side IP that faces toward the rest of the VPC, the rest of the instance. So like if I let's take one of these EdgeConnects here, right click, and then go to deployment. So this is what the EdgeConnect looks like logically as a router. There's this side over here is the WAN side. This is where the internet connectivity exists, and the left side is the LAN side. So this would be the side that's facing toward the VPC. Or if you're at a branch location, for instance, let's come down here and take a look at my home office, for instance. I click on this guy, go to deployment. We'll see that the EdgeConnect has this guy is in a redundant pair, and there are a total of 4 WAN side connections. There's an INET A, B, C, and then there's an MPLS 1. So you have all of your underlays or your WAN side connectivity on the right side and all of your LAN side connectivity on the left side. So the automation sets up and creates all this stuff for you.
Adam, can you show some BIOs and just a little
Yeah.
bit more of that?
Yeah,
Because I
let's do
think
that.
if we get into Cloud WAN, it'll be important for folks to understand the overlays and
That's right.
What's a BIO?
business intent overlay. That's the abstraction that we have. So all this, the conversation so far has been kind of how you bring this up in kind of an inner networking and routing environment, but then we lay down these virtual networks over top of the underlay physical network that's getting plumbed in, and that's where the real magic of the SD-WAN comes to life, is in these virtual networks that are shown here, 1 to 6.
Yeah, that's right.
Adam, can you bump it up one more? Sorry. If
Yeah, I was
possible.
trying to. I went down. I was like, nah, it's gonna be too hard to see. Let's do that.
Yeah.
So the business intent overlays are like
There we go.
logical networks. They're like, imagine each one of these is a topology. Each one of them is a set of interconnectivity rules that govern a particular type of traffic. Take, for instance, this is our real-time overlay. The way it works is packets come into the EdgeConnect, like you're at a branch location, you're sitting on the LAN side of the EdgeConnect at your computer. You want to connect to Zoom.com or whatever the application is that you deem as being real time. The packets come into the EdgeConnect, they start falling down through this stack of overlays. The first overlay that they match, the traffic kind of falls down and then starts and gets caught by that overlay. It matches into that overlay, and that flow or that connection adopts all the characteristics of the overlay that it matches against. So let's click on the real-time overlay here. So the way you decide what traffic is real-time, what traffic gets treated as real-time traffic, is by interacting with this access list. So you can match on all kinds of different things. You could say, well, I want to match on Ring Central traffic. So I want Ring Central traffic to be considered real time, or I want Teams traffic to be considered real time. You can even do stuff like you can specify go down to user role, and you can say I want any traffic from Adam Powers to be treated as real-time traffic. So the system does radius snooping. It has VXLAN GPID integration. We have integration with Aruba's ClearPass technology. So the EdgeConnect can be made aware of individual users and what IP addresses users are associated with. So then you can make routing decisions, policy, QoS decisions, steering decisions based on a role or based on a username. Device type, MAC address, and so on. So you populate the business intent overlay with these access lists that control what traffic is considered real time, what traffic is considered recreational, and so on. Once you match the traffic into an overlay, there are 2 types of fundamental actions you can take. There's this first, there's 2 tabs here. This first tab is for traffic going from one branch to another. Essentially, it's the best way to think about it. This is where you'll choose the topology. Like for the, let's say, for our global SD-WAN fabric, do we want to form tunnels between our branches in a full mesh? Or do we want to form IPsec tunnels between our branches in a hub and spoke topology? You simply pick the way you want the EdgeConnect, the SD-WAN fabric to function, or the way you want it to be constructed, and the business intent overlay here will build tunnels and configure the interconnectivity between the branch locations in accordance with what you've selected in this list. For this deployment, in this environment that we're looking at currently, we're using a regional hub and spoke. That means that for each region, you have a hub, and all the branches within that region will connect to that hub. And then, so if you want to route from a branch on the East Coast to a branch on the West Coast, you would go East Coast branch to East Coast hub, East Coast hub to West Coast hub, West Coast hub to West Coast branch. It will route across the SD-WAN fabric automatically for you like that.
Yeah, so this actually brings us, like after Adam talks about the inner details of the business intent overlays, you can think about the hubs that Adam mentioned as the EdgeConnect SD-WAN instances that are running in AWS. Now, for instance, if you have a branch office, let's say in the West Coast, maybe let's say in San Jose, a physical store, that store has an EdgeConnect instance running. What we recommend is that you deploy an EdgeConnect instance in AWS California, and that becomes your hub appliance for your West Coast branches. Similarly, if you have another branch office, like let's say in New York City, what we recommend is that you deploy an EdgeConnect instance in your AWS Virginia region, and that becomes the hub for your East Coast branches. And now, inside the AWS backbone, we can form tunnels so that you can have a protected middle mile and an optimized middle mile that's provided by AWS. So after Adam talks about like the business intent overlays, we can talk about that specific use case, and you can showcase some of the things that we have seen by running some actual traffic across the AWS backbone versus going over the internet.
I also realize that we're chewing through time.
We ought to transition that way. I think that's a
yeah,
perfect way to sort of segue.
Crazy how fast the time goes here.
Towards middle mile and
these overlays help you control how you're going to route traffic. If you guys are familiar about the last comment I'll make on this, if you're familiar with the SSEs or ZTEs, they're called different things, Zscaler, Netscope. You can see we support all of these guys. So like if you're a Zscaler customer and you want to route traffic from a branch office to Zscaler or to our own product, is Access Security. We recently acquired these guys. It's this guy. You just drag it over into this policy order, and now any traffic that enters the real-time overlay that's going to the internet will route through Access or through Zscaler first before it goes to its final destination.
And then you've implemented SASE. So that's
right.
end-to-end SASE architecture that Gartner and others talk about. It's the combination of the SD-WAN and those cloud security solutions.
That's right. So as far as the backbone discussion, as we transition into that, let me show you something real quick. So I can pick any two AWS instances. Let's do Sydney to Northern California. I go to monitoring. And let's do latency. Let's do 1 day, and let's take a quick look and see what is latency. This is per minute over. So the EdgeConnect keeps track of latency, loss, jitter, and then a final MOS score for all the tunnels for between each branch, from branch to hub to hub. Also keeps detailed information about the performance and characteristics of the connection between those branch locations. So here we can see that that it's very flat. So when you're looking at a latency chart, this is very typical for AWS middle mile or AWS backbone connections. It almost looks glitched. Like it looks like it's not doing what it's supposed to. I'm going to do lock scale. That'll make it a bit more obvious. Look how extraordinarily flat that is. This is a very high resolution measurement that's being taken. It's 2 packets per second in each direction that are scoring this number here. So if I want to go from Northern California to Sydney, it is precisely 137 milliseconds all the time, continuously, which is very nice. So this is called path char, or path characteristic mechanism within the EdgeConnect. We use these latency stats to decide which path to take, which way to route. But my point here is that if I pick any two endpoints between, let's go Bahrain to Montreal, again, I'd be quite surprised if we don't see a really boring, very flat connection from Bahrain to Montreal. So the reason why that's relevant, important here, is because if I have a branch office in Bahrain, or in the Middle East, and that branch office wants to talk to a device or another branch office that's somewhere in, let's say, Montreal area, the way that will work is the traffic will go from the branch into the Bahrain hub. It will then transit the AWS backbone across the AWS infrastructure to Montreal, and then from Montreal to the branch. And that network latency from Montreal to Bahrain, again, extraordinarily flat. So this is what you want to see when you're looking at network performance characteristics. You do not want any drama. You do not want jaggedness or ups and downs. You want the latency to be as flat as possible, and that's the dominant characteristics of AWS middle mile performance is it's boring because it's so flat, which is a good thing.
I've never heard of latency being called drama. That's
I could find, so I'll show you my Starlink connection from my house to really anywhere, and it will be dramatic. There will be a lot of jagged ups and downs, but that's just not what you see on these high speed middle miles. They're very, very good as a transit provider.
Quick question, Adam.
Yes.
How does Direct Connect fit into this whole configuration, or does it at all?
It does. Yeah, good question.
It can. Yep.
That's a good question. Yeah. So in fact, it's better. In fact, like we do like if a customer can attach a direct connect link to an EdgeConnect instance, because the advantage of an SD-WAN instance is that the more WAN transports you attach to it, the better. So if you have two ISPs, that's better. But if you also have, like, let's say, a direct connect link, what the SD-WAN software can do is it can form an SD-WAN tunnel over that direct connect link to the on-prem direct connect location where the direct connect link terminates. So now what the customer gets out of that is, apart from being able to route traffic over the internet, now the customer can also like route traffic over the direct connect link as well. And as Adam will be showing, if there are any brownout or blackout conditions on the internet link, we can automatically switch that traffic to take the path that's going over the direct connect link, and the application would not know that there's been such a switch. So that's the benefit to the application.
So that's drama right there. In case you're wondering, this right here is not what you want to see. So that's a Starlink. Now, I mean, I love Starlink. I think low Earth orbit stuff is the way of the future, but it has a ways to go to match the kind of performance you get from physical terrestrial connectivity. So that's a lot different than that's what drama looks like. I think direct connects and MPLS, all those I think it's overrated. I just don't. You can, if you just get two cheap internet connections, Comcast, AT&T, Verizon, Comcast, just find any two internet connections. It doesn't really even matter what the quality is, and bond them, put them both together, and you'll have the equivalent of a high-speed, expensive, dedicated link. This is what's made SD-WAN so popular, is people are slowly or have finally discovered the fact that you really don't have to pay. This could be unpopular sentiment with some people, but you really don't have to invest in these super deluxe point-to-point connections, because multiple internet connections can be bonded together to meet the equivalent of what you would get from one of the individual links. Of course, if you want to get a high-end point-to-point link and combine it with one or two more internet connections, it's even better.
So this could be way off, but is it? I mean, just mentally, and would an analogy be kind of like to torrenting, like where it's multiple connections making one really fast kind
That's
of
very
thing?
good.
Yeah.
That's it's a lot like that. It's called path diversity. The idea is you
Yeah. Okay.
take multiple different paths. It doesn't really even matter if one's better than the other. It's just they're different.
Yeah.
Regarding that, I can't show it right now because the system's not set up for it. But AWS offers IPv6 addresses, so you can put a v6 address on your EdgeConnect, and you can put a v4 address on your EdgeConnect both at the same time, and you form tunnels across the v6 path and tunnels across the v4 path. And in practice, if you look at the performance and latency, they are different. For whatever reason, the infrastructure that routes v6 is different from the infrastructure that routes v4. And it's not that one's faster than the other, it's just that they are taking different paths. So what that means is if there's an issue along the v4 path, then that's fine because the EdgeConnect will instantaneously adopt and route the traffic across the v6 path. So all we're after with SD-WANs and routing in general, especially on the WAN side, is diversity, not really so much quality. So multiple diverse paths is better than one quality path.
This is the other analogy here is in storage is to a RAID array, right? Where you take a set of less reliable disks and you do erasure coding, right? So you have more, you consume more storage, but through the coding algorithm, you can suffer the loss of a less expensive disk, right? And so the same idea is occurring
That's right.
here. We're
RAID 5.
coding the data, we're sending coded data down all these links, and then reassembling and handling packet loss at the other end by through the erasure coding actually being able to piece the, you send 1.3 times the amount of data to get 1x out, right? And the additional 0.3x is the coding overhead that you spread across the links, and it allows you to
It's just like
reconstitute
that.
everything.
It's like RAID 5. Like, so I have a Synology drive in my garage, 3 disks, one of which is just giving up parity, just parity. In our world, we call parity FEC. It's forward error correction. If you want to kind of Google it, it's
FEC
very
is
well.
the networking.
FEC. So FEC, the downside is that you had 3 disks, 1 terabyte each. You have to give up 1 terabyte. But cool part is you can just pull one of those 3 disks out completely. It can just disappear and nothing changes because you can continue to operate on just 2. Now you can't pull 2 out. If you take 2 of the 3 disks out in your RAID array, then you're toast. But that's what the EdgeConnect is doing. But all these green lines, they're running this FEC or this parity mechanism that bonds multiple internet connections into something that feels and looks like RAID 5. Yeah.
And the overhead across the network is sort of 10 or 15%. You can get 99.999% recovery for given the distribution of loss in the network, right? It's different than storage in that sense, right? So it's a bunch of advantages, but that's the same idea. So it's not and that's why you have to have an edge connect at either end. So anytime you're doing this, it's a bookended solution. We need to put the data down the links and then pull it out the other end.
Yep.
I have a question.
Yes, sir.
Sorry, apologies if this takes you a little out of what you're trying to talk about. So
no, it's okay. We need to switch gears. We've gone.
What would be the advantage of SD-WAN over creating a lag? I remember you said, it's combining multiple.
Lag is like the LAN side, the Ethernet, the high speed. Lag is a lot. It has some care. It's similar. Mm-hmm. If you have a physical Ethernet cable between this guy and that guy, you plug them together and you bond to multiple.
So the reason
channel are very similar.
The reason I ask that is, if you go for the maximum resiliency for direct connect, where you have 4 different connections, right? Going from different devices and from different providers, right? So what would be the benefit of using the SD-WAN at that point over just creating a lag so you can get more throughput?
How do you create a lag from a branch office that's 300 miles away from the AWS data center? You can't do that, right? So lags and that kind of thing, those work for cross connects when you have direct Ethernet.
It's a layer 2 technology generally, right? You don't do layer 3 lags, do you?
Yeah, that's right. But I'm in the middle of Ackworth, Georgia, and I don't have direct cross connect to AWS or anywhere else for that matter. I got Comcast cable, I got Starlink, and I got a T-Mobile LTE modem. So, but it's the same principle.
It's
It's the
similar
same.
for sure. Yeah, you're thinking about it the right way, but
Yes, that's right.
yeah.
That's right.
Plus, at the same time,
a lag isn't going to do that erasure coding that we were talking about, right? So it's not going to stripe the data. It's usually packet by packet down each link, and so there's
rapid detection of the link and then a quick failure.
I think there's
quick
some
switch
sort
over.
of intelligence behind the SD-WAN that can,
Exactly.
very intelligent lag
Yeah.
that's sort of oriented towards a wide
Yeah.
area network problem.
That's right.
Yeah,
2
plus-
packets per second each direction is what is used to detect the stability and availability of each of those underlays.
yeah, that's what about actually Fraser just said what was on my mind. We do measure like packet loss, latency, and jitter every second. So lag doesn't do that. Uh,
But again, it's just two different, similar principle. You're taking
Yeah.
multiple of something, putting them into a logical bonded thing,
Mhm.
and then if one of the things in it fails, then it's okay. You keep going. But this is doing that across unlimited distance, thousands of miles potentially. Whereas you can't do that with the layer 2 technology in that situation.
yeah. So
Thank
I
you.
guess to switch gears, I guess maybe we can start talking about using AWS as the middle mile for site to site. Although we touched on it briefly, we can show some like concrete results of a test that we did recently.
Let me stop sharing. I think Dinesh, you've got some of those stats, right? I do not have those available.
Yeah.
Okay.
Oh, if I can share my screen.
Oops, sorry. Yeah, someone removed there. There we go.
Yeah. So that's the second use case that we wanted to talk. So
we're a little behind.
Oh boy.
Maybe you guys will have to have us come back to finish the other
Yeah, I was gonna
5
say you're
bullets.
welcome to come back. Yeah.
Good
Yeah.
grief.
So just like the appliance that Adam showed on our SD-WAN environment, here in the diagram we have two sites. We have like New York City, a branch. In fact, like this is the server. The test we did was we had some clients in Melbourne, and they were trying to reach an application in New York City, and over the internet. Well, that's what like most enterprises do before they start deploying SD-WAN in uh, uh, AWS or start using AWS as the middle mile. But as 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 we've been talking up to now, what we recommend is that you deploy either one or two edge connects that's closest to the branch office. So in this case, since the server is in New York City, we have picked Virginia as the region where we deploy the EdgeConnect instances. And then in Melbourne, the closest AWS region is in Sydney. I believe these days you also have an AWS region in Melbourne, so we could have, in fact, deployed these plans in the Melbourne region as well. And then what we did was we established like VPC peering. This doesn't have to be VPC peering. You can have, if the customer already has something like a transit gateway or a core network edge in each region, they can peer those two together, and the SD-WAN instances can establish the tunnels over that connection instead of VPC peering. But we went ahead with creating VPC peering because that's the simplest way to connect two regions together. And then we created one extra interface on the SD-WAN instance so that it can create a dedicated tunnel from that interface to the remote EdgeConnect instance over the AWS backbone. And the result we saw was when going over the internet from Melbourne to New York City, the latency was around 270 milliseconds. And when we took the AWS backbone, uh, like this tunnel shows 220 milliseconds. So even though we are uh, adding like a couple of hops from the Melbourne side, so uh, without these EdgeConnect instances in AWS, the customer would go directly. But even after like adding a couple of hops from Melbourne to Sydney and from New York City to like Virginia, the latency is 50 milliseconds lower than what a customer would see when like going over directly over the internet. And so this is from the application's perspective. You see the bottom line here, which shows traffic going over the AWS backbone, and the top line shows traffic going over the internet. And we measured that like this gap here is approximately 14 hours. So for 14 hours, uh, like latency over the internet, it went up to around 320 milliseconds. But like during the same time, it's maybe like a like a 6 millisecond increase on the AWS backbone. So there's a huge gap when you send traffic over the AWS backbone versus like sending traffic over the internet. Yep. So that's the second use case. I believe the next one is um, now when you deploy an EdgeConnect in the cloud, in this case in AWS, like let's say you also have some workloads in that same region, and basically how do you redirect traffic from those workloads in that region to the SD-WAN instance? So typically, but when customers typically starting out with AWS, they may have only like one or two VPCs, and maybe the workload that they are trying to reach is not critical. If that's the case, then and also if they don't mind like losing the EdgeConnect instance, maybe when it's upgrading, meaning that they don't need high availability. Typically, what we ask them to do is like deploy the EdgeConnect in the cloud and create a route in your VPC route table to forward traffic to this instance. So that's how you like redirect traffic from a particular region into an SD-WAN instance that's running in the same region. Now, for some enterprises, in fact, for most enterprises, um, you probably have like more than one VPC in your region, and when the, and that happens, like that's when you need. I'm gonna skip this one. Is next one which talks about like VPC peering limitations. But when companies have more than one VPC in a region, um, they would at that point they would probably uh, deploy a transit gateway because it simplifies networking in that region. And as we know, you can connect multiple VPCs to a transit gateway. You can terminate an IPsec tunnel or GRE tunnel or a direct connect link, or you can connect the transit gateway to another transit gateway, maybe in the same region or in a different region. So now in this architecture, um, when the customer has multiple VPCs, I'm showing like two VPCs here, but it could be hundreds of like VPCs. You can connect all that to the transit gateway, and from the transit gateway, you create a static route that's pointing to the EdgeConnect instance. So if you want to use static routes, as I'm showing on this slide, it's quite a bit of static routes here. First, you have to create a static route in your spoke VPC where you run the workload, saying that, hey, if you want to go to the destination, which is in my diagram, the destination is the data center. Your next stop is the transit gateway here, and once traffic gets to the transit gateway, you say, hey, for the same side range, your next stop is the SD-WAN attachments, which is this guy. And when traffic gets to the SD-WAN VPC, you create another static route saying that your next stop is the LAN 0 interface of the SD-WAN instance. So as you can see, there's like quite a bit of static routes involved here. And for return traffic to go back to the workload from the data center, you also need to create some static routes within the SD-WAN software, because the SD-WAN software doesn't know about these VPCs. So like over here, I'm showing those static routes. Um, what we recommend to customers is that when you have multiple VPCs, it's much better to use the transit gateway with BGP. So as as we discussed earlier, the the transit gateway supports like BGP over GRE or BGP over IPsec, and typically BGP over GRE like gets you higher throughput, up to 5 gigabits per second per GRE tunnel. So that's what we recommend. And in this architecture, when you have a transit gateway with the GRE tunnels, all you need to do is now you still need the static route on the spoke VPC to forward traffic to the transit gateway. But after you send traffic to the transit gateway, um, you only need to set the the route type
Good.
to propagate it so that the SD-WAN, the routes that it's propagating will start showing up on the transit gateway. So those are the only two like routes you need to create this architecture. So it simplifies a lot of networking with this
So this,
architecture.
what you're showing here is like complete, is fully redundant from top to bottom, like all the way from the data center, even the WAN side, right? You got an internet connection and a direct connect. Those are going to get bonded together. The green and the orange lines, guys, we're going to bond those together into a bonded SD-WAN tunnel. And then those are going to go to a pair of edge connects, which both have a GRE or IPsec tunnel running BGP to the transit gateway. And there's actually two transit gateways, right? Like you're showing one here, but logically there are two of them. Um, so no one thing can fail here. I guess you're showing the data center EdgeConnect is just one, but in practice that would be two also.
In
So
practice,
everything
that
from
would
your
be two
WAN
as well.
transport,
Yeah.
yep, everything in this entire diagram is fully redundant from a routing standpoint. And the only static thing you have to configure is the propagated route from the VPC itself, pointing toward the transit gateway.
Yeah.
This is kind of it sort of looks a little complicated initially to set up, but it's really solid once you get this done.
Yeah. And the next thing is that integration with AWS Cloud WAN. So like basically using transit gateways as you know, it can be a little cumbersome when the environment is segmented. Now here what we are showing is that you have an on-prem environment which has two segments like production and non-production. And if you want to have those segments uh, preserved when you move application to the cloud, you would probably create two VPCs called production and non-production. And basically now, like how do you map those your on-prem segments with the cloud segments? You can do that with the transit gateway. You can create up to 20 route tables inside a transit gateway. So what you can do is you can create one route table called a production route table and attach all your production VPCs to that production route table. And you create the second route table, call it the non-production like route table, and attach all your non-production VPCs with that. But when you have multiple VPCs and when you need multiple segments, it becomes quite cumbersome to create those route tables inside the transit gateway. Now, also, if you have a globally distributed AWS footprint, meaning you have like transit gateways in different regions, it becomes even more complex because now you have to do this in each region. So that's why AWS introduced what's called AWS Cloud WAN. And we have integrated with Cloud WAN um, to simplify this. And basically what we allow you to do is um, create this environment and stitch it with your cloud segments. Pretty much what I'm showing here is that we have the on-prem segmented environment. We have, again, the production and the non-production segments in your on-prem environment. And uh, EdgeConnect supports segmentation. So when you communicate between two on-prem sites, we can preserve segments, and we allow that traffic to communicate securely between your on-prem segments. But when you also have a cloud uh, footprint, basically that's when AWS Cloud WAN comes into the picture. So now using Cloud WAN, you can create these core network edges in each region. Like think of this as your transit gateways. So in the Cloud WAN environment, uh, a way I think about the core network edges is that this is another term uh, to refer to a transit gateway. Like behind the curtain, it looks and feels like a transit gateway, but the term that the Cloud WAN architecture uses is slightly different. Instead of calling it a transit gateway, now it's called a core network edge. And in just few clicks from the AWS dashboard, you can create these core network edges in multiple regions. Uh, in the past, when you worked with transit gateway, you had to create these
Pick a region.
transit gateways in each region one at a time. And so now in this architecture, you can create segments from the AWS dashboard that's that are spanned across multiple regions in AWS. And you can place your VPCs into these segments. Now, in this architecture, your non your non-production VPC cannot communicate with your production VPC unless you want them to. You can configure that. So if you're familiar with route leaking, those capabilities are available in Cloud WAN as well. But by
So Dinesh,
default,
the segments are like VRFs, right? Like I know we're using
exactly.
the lingo that AWS uses and that EdgeConnect Aruba uses. They're called, so we call them segments, but they
Yeah.
are VRFs. They are autonomous routing domains. Like if you're in the blue segment,
Yep.
it is not possible for you to route to or go to the green segment. Those two cannot talk, even though they're in the same box and they're in the same thing, the same physical router. They are completely isolated from each other. These are VRFs, and we can do end-to-end VRFs in this case.
Exactly. Yes.
And I have a quick question. So going back to when we were showing Adam what you were showing, you were able to prioritize, different users and different, all sorts of different things. So in this
Yeah.
case, we'd be able to prioritize like the prod segment, give them more juice,
You
more,
can, yep. You can indirectly. So we have what's called a QoS policy, and you can decide what traffic matches what traffic class. So you can put certain types of flows, maybe they're production flows, you put them into traffic class production, and you put non-production flows into your best effort traffic class, and then you can set thresholds on how much of the traffic these different traffic classes are provided. So you can do bandwidth allocation, and you can turn on or off an intrusion detection system based on, turn on the built-in IDS IPS in the EdgeConnect based on these characteristics. Yeah. But the main value here is being able to like have these isolated concurrent networks across your entire network, from one branch through the AWS cloud infrastructure across the middle mile into the other branch without having to think much about it. Like everything we're showing here, like a lot of it does looks a little bit overwhelming. We're automating all of this. So you just press a couple buttons, hit go, and it sets up all these segments. It configures all these tunnels. It does all this for you without having to have deep knowledge of the individual artifacts and how you configure them.
And for Aruba, this segmentation extends way back into the rest of our infrastructure in the campus or in the enterprise
Yeah,
environment. So through the wireless and the switching,
becomes
all of
roles. Yep.
this is end to end for us. And so really the AWS piece completes the stitching of it from end to
Yep.
end.
We go from VXLAN VNI to the EdgeConnect through AWS as a segment to the other end, then it gets turned back into VXLAN and translated into a VNI.
I got a question concerning what Dinesh mentioned earlier when he was talking about the route table, because I know it can get crazy really quick when you have multiple routes that you're trying to configure. So, do you have any way to automate the route creation?
So we establish BGP. Now,
Okay.
I stopped in the middle of this diagram. Now, the question is that, okay, now you have the segmented environment in the cloud. You also have a segmented environment on-prem. Now, basically, how do you stitch those two together and send traffic segmented end to end? The way you do that is you go to the Aruba orchestrator, you deploy these EdgeConnect instances in each of your regions. And at this point, from the orchestrator, as Adam showed earlier, once you push your business intent overlays into the EdgeConnect instances, they will start building these IPsec tunnels across your internet link and across your direct connect link to your on-prem environment. So you have from your on-prem users, you have now connectivity up to the EdgeConnect instance. Now, at the moment, what you are missing is this this is LAN side connection from your SD-WAN instance into the core network edge. So uh, we are in the process of automating that on the orchestrator. So what we do is we create GRE tunnels. For each segment, we create a unique GRE tunnel or unique IPsec tunnel to your core network edge in that region. And to do that, if we take a closer look at this link between the EdgeConnect instance and the core network edge, we create this VPC attachment from the SD-WAN VPC with the core network edge, and then uh, the orchestrator automatically creates what's called a connect attachment, an AWS connect attachment, and then inside that we create a connect peer, which translates to a GRE tunnel. So if you have three segments, if you require three segments in your environment, we create three GRE tunnels. In my diagram here, I'm showing two segments, and I'm showing two GRE tunnels. And inside each GRE tunnel, we establish BGP. So, like Olabanji, to answer your question, like once the orchestrator establishes these BGP sessions with the core network edge, you no longer have to touch your route tables because the route exchange happens over using BGP.
The only consideration is just route table size, right? What is the Dinesh? 1,000 routes?
It's 1,000 routes. Yeah,
1,000 routes. Used to be 100. That was
it's 1,000.
100 was a bit cramped. 1,000 is still a bit cramped for most enterprises. You can summarize. There's ways to get around it, but 1,000 routes is, I think, the biggest consideration from a
Yeah,
scaling perspective.
and to create that like LAN side connectivity from the EdgeConnect instance in the cloud with the core network edge, we ask the user to like go to the orchestrator, create what's called a LAN side label. So I think of this as assigning some kind of a string to an interface on the EdgeConnect instance. So in this case, this is the LAN side interface that's facing the workloads inside AWS. So we assign it a label, and then uh, we place that a label on the deployment page of the of our software, and we say that, hey, from this label, establish tunnels to these two segments in the core network edge. And the last screen here is that now the orchestrator wants to know, okay, which core network edge does the appliance need to connect with? So if you have appliances in my example, I have two appliances in San Francisco. So I'm connecting with my core network edge in California. And my appliances in Virginia connect with my core network edge in Virginia. So that's what you select here on the orchestrator. And at this point, orchestrator will go ahead and start building those GRE tunnels on the LAN side. And when everything is ready, when both GRE and BGP are up and running, you will see the connection status as up. So at this point, you have this end-to-end stitched environment, and uh, your users, your on-prem users, in this case, in my production segment, these users will be able to access the workloads in the production VPCs in the cloud over the SD-WAN fabric, over the core network edge, without the customer having to like mess with those route tables inside the transit gateways, like when they didn't have cloud WAN in the past.
Cool.
So this is sort of a feature that is currently in the works, and we are planning to have it available probably by the end of this year.
Yeah, that's the cloud WAN
Awesome.
automation, right?
Yep.
Cool. I think we actually got through most of the topics. I imagine we could come back and talk about there's other things we could discuss in the future if you guys, James, want to have us back again. But I think
Certainly
yeah.
showing
I
this
think we're kinda,
automation as we get it into the
yeah,
product,
yeah,
right?
as it's ready. That's right.
Yeah, absolutely. Yeah, when that'd be perfect when it launches, we could bring it back, cover anything we missed, and then go over the launch for sure, or the features.
Deploying EdgeConnect without the EIP limits or whatever you had that you ran
Yeah,
into, right? The permissions, right?
Yeah,
turbot limit.
yeah.
That's
Maybe
right.
I'll work on my demo
The
presentation
permissions.
a little
Yep.
better. All right. Cool. Well, thanks, guys.
Yeah.
Yeah, no, don't
Well said.
even worry about it. You know, the demo gods, they're
They
fickle.
strike. Yeah.
Yeah,
It's
and
all right.
I always give the example. One of my favorite shows was when something didn't. I forget who it was. Something didn't work, and then we spent a lot of time, you know, just troubleshooting and got everyone involved. It was pretty fun. But yeah, no, thank you. That was awesome. Good stuff. Good information. Uh, check out everything we have. I dropped some links. I'll drop them again real quick. We have the marketplace link. We have, please fill out our survey. I'm going to drop that real quick, as well as connect with everyone at HPE Aruba, Fraser, Adam, Dinesh. Let me go ahead and pick those out again real quick. Is there anything else anyone would like to plug? Anyone TikTok famous on here or anything like that?
Not yet. I'm trying to be.
That's right.
I'm gonna follow you guys on LinkedIn right away and connect with you guys to
Yeah,
others.
let me
Awesome.
pull that out too. Here's a LinkedIn link in chat for people, and there's a pinned message with the HPE Aruba form, but I will drop that again once more. Uh, any last thoughts from anyone before we check out here?
Thanks for having us.
Yeah.
Yeah, no
Thanks,
problem.
guys.
Yeah, we'd love to have you back. Like I said,
We'll be
when
a big sponsor at reInvent this year, HPE. So we'll be there probably talking about this automation in November in Vegas. So right after
cool.
Thanksgiving.
Yeah,
Yep.
I don't have my ticket yet. I'm still looking how to get. I need to
Yeah, it's
find like
always
a
harder for you
talk or
guys to get
something.
in there, right? Yeah.
Yeah,
Yeah.
it's not free. They
Yeah.
have to have a reason for us to go. So
Right.
hopefully
Yeah.
I'll
Yeah.
get to meet you
Fun
guys.
one. Yeah, it's a good time.
Yeah. All right. Awesome.
Cool,
So I
guys.
dropped all that stuff in there. Sorry, but someone else want to say something real quick?
No, I was saying thanks for having us.
Oh
Appreciate it.
yeah.
Good
Yeah.
stuff.
No, this
Yep.
is great. Cool. And all right. Let me pull up our thing here. And with that, happy trails, everyone. Please connect with everyone and fill out our surveys. And we'll see you again next time. See you guys.